Hello guys, in today's video we are going to discuss the solution of the problem sum of products. So let us look at the problem statement. The problem statement says that given an array ARR of size n, calculate the sum of bitwise ANDs, that is calculate the sum of ARRI and ARRJ for all the pairs in the given array ARR where I is less than j. So let us try to understand the problem statement with the help of an example. So in this example, the array which is given to us is this, which is 5, 10 and 15, and the number of elements is 3. The possible pairs over here is 5 and 10, 5 and 15, and 10 and 15. So if we do a bitwise AND operation of these pairs, then 5 and 10, the bitwise AND of 5 and 10 is 0. Similarly, the bitwise of 5 and 15 is 5, and 10 and 15 is 10. And if we add this 0 plus 5 plus 10, we will get 15. So this is what we need to return. So that's about the problem statement, folks. Now let us go ahead and discuss the solution of this problem. So let us first look at the brute force solution of this problem. So in order to discuss the brute force solution, let us take the example which we have, where n is equals to 3 and the elements of the array contains 10, 15 and 20. So in the brute force solution, what we are going to do is we are going to generate all possible pairs. Once we have generated all the possible pairs, we are going to iterate on all the pairs, and while iterating on the pairs, we are going to compute the AND operations between the elements of the pair. And the value obtained after computing the AND operation of the element of the pair, we will keep adding that value in a variable, let us say answer, and towards the end we will go ahead and return answer. So that's about the brute force solution, folks. Now if we analyze the running time complexity, the running time complexity will be determined by this step, which is generation of all possible pairs. And as we know, the time it takes to generate all possible pair is n squared. So why is this n squared? Well, if n is the number of elements, then the total number of pairs will be n into n minus 1 by 2, which is equals to n squared. So that is how we are saying that the running time complexity of our brute force solution will be order of n squared. So that's about the brute force solution, folks. Now let us go ahead and discuss the optimal solution for this problem. So as we have seen in the brute force solution, the problem with the brute force solution is we have to generate all possible pairs. Now in the optimal solution, what we are going to do is we will try to avoid computation of all possible pairs. So let us discuss how we can avoid the computation of all possible pairs. So for that discussion, let us take an example where n is equals to 4 and the elements which are given to us is, so let us say these are the elements of the array and we would like to compute the sum of and of all the pairs. So first what we are going to do is we are going to go ahead and represent each of this element in its binary format. So let us go ahead and do that. So this is the binary representation of each of the elements. So for instance 10, the binary representation is 1010, and just for reference I have just designated this as like this is my 0th bit, this is my first bit, this is my second bit, and so on. So this is the binary representation of each of the elements. So now let us go ahead and see how we can optimize our brute force solution. So essentially this is what we want to compute, which is the sum of and of all the pairs. So what we are going to do is we are going to compute the sum of and of all the pairs. So rather than computing the AND operation for all the pairs, what we are going to do is we are going to work with the bits of the element in order to obtain the same thing. So let us discuss how we can do that. So as we can see that the 0th bit does not occur in any of the elements. So the sum of 0th bit is 0 over here. So that simply means that the pairs formed by 0th bit is 0. Similarly, if we see how many times that does the first bit appears in all the elements, well, the number of times the first bit appears in all the element is 2 times. So since it appears for 2 times, so the number of pairs formed by the first bit will be, how many pairs will it form? Well, the number of pairs will be 1. So how are we coming to this conclusion that the number of pairs is 1? Well, the way we can compute the number of pairs is k into k minus 1 by 2, where k is the number of times the bit appears in array. So for instance, the first bit appears for 2 times in the array. So if we put the value of k equals to 2, then the value we will get is 1. So that is how we are saying that the number of pairs formed by the first bit is 1. And which is that pair? Well, that pair is 10 and 30, right? The pair over here is 10 and 30. This is the pair which will be formed by the first bit. Now let's move forward. The number of times second bit appear in the array is again 2. Here, this is first time it is set to 1, and this is the second time it is set to 1. So that is how the number of times the second bit appears in the array is 2. So similarly, the number of pairs formed by the second bit will be 1 again in this case, and the pair which we are looking at is 20 and 30. See this, 20 and 30. So that's the pair which is formed over here. Moving forward, the number of times the third bit appears in the array is how many times? Well, it appears for 3 times. Now since it appears for 3 times, then the number of pairs formed by the third bit would be how much? So let us plug the value of k equals to 3 in this equation. So 3 into 3 minus 1 by 2, which is equals to 3. So the number of pairs will be 3. And if we want to count what pairs does it exactly form, so the pairs it will form will be combination of 10, 30 and 40. So the pairs would be 10, 30, 10, 40 and 30, 40. Similarly, the number of times fourth bit is set to 1, or the number of times fourth bit appears in the array is 2 times. So the pairs formed by the fourth bit will be 1. Similarly, the number of times the fifth bit is set to 1 is 1. So the number of pairs formed over here will be 0. So once we have this information that the number of pairs formed by each of the bit, we can use this information in order to compute the sum of and of pairs. So let us see how we can compute that. So the first thing which we understand is the 0th bit, the number of pairs is 0. So this is simply 0. The first bit, the number of pairs is how much? 1. So this will be this. The second bit, the number of pairs will be how much? Well, the number of pairs for second bit is again 1. So this is how much it is. Similarly, the third bit, the number of pairs will be equals to 3. And fourth bit, the number of pairs will be equals to 1. And fifth bit, the number of pairs will be equals to 0. Okay. So this is how it will look like. And eventually, let us now expand this. So see, here we are multiplying it by 0. So I'm just writing it down as 0. So first bit, the first bit is essentially 2 to the power 1, right? Into 1. The second bit is essentially 2 to the power 2 into 1. Plus third bit is 2 to the power 3 into 3. Fourth bit is 2 to the power 4 into 1. And fifth bit is 2 to the power 5 into 0. So now let's evaluate this. So this is equals to 2 plus 4 plus 8 into 3, which is 24, plus 16. And if we add all these values, what we will get? We will get 46. And this is what you will get if we go ahead and compute this equation. So that's about the explanation, folks. Now let us go ahead and discuss the pseudocode for this problem. So what we want to do is we want to find the pair and sum, and n is the number of elements and the array is this. So the first thing which we want to compute is how many times a particular bit is set in an array. So let us do that. So let us say for I in range of 27, And the reason why I am taking 27 here is because in the question it is mentioned that the maximum value ARR I can have is 10 to the power 8. Now if you go ahead and take a log base 2 of 10 to the power 8, you will get 26 point something, which I am roughly translating it to 27. So 27 bit at most we could have. So that is why I'm just iterating on only 27 bits. Now for each of the element, we would like to see how many times a particular bit is set to 1. So initially the number of times the bit is set to 1 is equals to 0. So let us set it to 0. Now we will iterate on each of the elements of the array. And while iterating on the elements, we will check if that particular bit is set to 1. So element and that particular bit. So that particular bit is something 0x1, and let us left shift it by how much? I times, right? So this will essentially give me whether the ith bit is set in element or not. If the ith bit is set in element, then we are going to go ahead and increase num bit by 1. So here the number of bit will be increased by 1, otherwise we'll just move on to the next element. And once we have identified that the particular bit is set for num bit times, now is the time to compute this part. So let us go ahead and compute this part. That we can do it like this. So answer will be equals to answer plus, so the ith bit. So ith bit is 2 to the power I. So this is what I am going to do, 2 to the power I. So this is my 2 to the power I, and the number of pairs. So remember, the number of pairs will be given by k into k minus 1 by 2. So let us do that. This is my answer, and towards the end we are going to simply go ahead and return answer. And please note the initial value of answer is 0. Okay, so that's the pseudocode, folks. Now let us see how we have coded this in Python. So the code is pretty much the same what we have discussed in the pseudocode. We don't really need this, so let me just get rid of this. So here answer is equals to 0, and we are iterating on the number of bits. And then for each of the element, we are checking how many times the ith bit was set to 1. Let us say it was set to 1 for num pair times. Then we are computing 2 to the power I into the number of pairs, and we are adding it to answer, and then towards the end we are returning answer. So that's the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.